Okay, so this is 7-2. Okay, this is the problem down here, and we want to find the center vertices, foci, endpoints of the minor axis, and sketch it. So first thing we need to do is put this in standard form. So like you did on the warm-up, take a minute, complete the square so you can put it in standard form.
Is that 64?
Yes. Should be completing the square here. So group your x's and y's together, move the constant over. Complete the square on x and y. Make sure you factor out those leading coefficients. Some time to get this one finished. Kyle, what number did you use to complete the square for x?
9.
Okay, good. So it's b over 2 squared. So that's -6 divided by 2 squared, which is positive 3 squared, which is 9. So then over here, I'm doing 9 times 9, which is 81. Okay, Cindy, what number did you use to complete the square on 1? Okay, 4. So negative 4 divided by 2 was negative 2, and negative 2 squared was positive 4. So over here, that's actually 16 times 4, which is 64. Okay, good. Okay, then I do the factoring. So, Brianna, what does the x's factor to? Good, x minus 3 squared. Plus, Adam, what do the y's factor to? Y minus 2 squared. Thank you. This will help him. So you factor out the 9 here on the x and the 16 on the y. So those just have to stay out front. Okay? Equals, then over here we have 144. Okay, we have our last step. Carly, okay, what do we do? Okay, good. Divide by 144 and then reduce with the numbers out front. So I get x minus 3 squared over 9 over 144 reduces to 1 over 16. Okay, plus y minus 2 squared, 16 over 144 reduces to 1 over 9. And then equals 1. 144 divided by 144 is 1. Okay? Again, so this kind of happened yesterday where the 16 and the 9 look like they switched places. That's just coincidental. That's because 16 times 9 is 144. But that's not always going to happen. Okay. So it wants us to find our center and vertices. So our center would be what, Dorian?
It would be 3 and 2.
Good. So opposites, so 3, 2. And then we want to find our vertices. So at this point, I'm going to go ahead and graph the ellipse so I can find the rest of this easier. Okay, so my center is at 3, 2. All right, I need my center and then I need A and B so I can find the distances. So Susan, what would A be? If A squared is 16, good. Good, and then let's see, B would be 3. A is 4, B would be 3. So 4 units, A is the horizontal distance, so 4 units left and right. Okay. B is the vertical distance, so 3 units up and down. Okay. Then go ahead and sketch in your ellipse. Okay. So the vertices are on the major axis. So Olivia, which one's the major axis, the horizontal or the vertical? Horizontal, because that is the bigger one. So these are my vertices. So I'm going to label those points. I'm going to write them as ordered pairs so we get their location. Okay, so that's 4, 5, 6, 7, 2, and negative 1, 2. I think foci was next. Yeah. Okay, so for foci, we need to use our equation, the a squared minus b squared equals c squared. Remember, we use absolute value because it can't be negative. So a squared is 16, b squared is 9. So we get 7, and then the square root of 7 is c. Okay, so that is about 2.65. So on our graph, from our center, we'll go left and right 2.65. The foci are also on the major axis. So since the major axis was horizontal, that's where I have to put the foci. So a little over 2.5 and a little over 2.5. That's fix that here. Okay. Now I have to write their location. So I need to write this as an exact answer. So as an ordered pair. So what I did to place the foci is that I went right and left about 2.65. Well, that's square root of 7. So I went right square root of 7 and left square root of 7 from my center. So this is at 3. So I went 3. From 3, I went right square root of 7. Okay, so that's 3 plus square root of 7. And I didn't move up or down from the center, so my y coordinate was still 2. And then I went left square root of 7, so 3 minus square root of 7. 2. And then we wanted to find the endpoints of the minor axis. Okay. So the minor axis is the vertical axis. So those points then are 3, 1, 2, 3, 4, and 3, negative 1. No, 1, 2, 3, 4, 5. That should be 3, 5. 3, 5. And 3, negative 1. And then part E was the sketch. Any questions about that? This is something you'll have to do on your quiz. You'll have to put the equation in standard form, graph it, label its parts. Okay. Now we're going to work backwards, and we'll be given some parts of the ellipse, and we want to write the equation. So I have to put these on a graph to be able to determine what I'm given. first of all, the equation of an ellipse looks like this. So I need the center, and I need A and B. So let's figure out what I have. So I have vertices at negative 6, 0, and 6, 0. Okay. And I have foci at negative 4, 0, and 4, 0. Okay, so do I know what the center is? Yeah, the center has to be 0, 0 because it's equidistant from the vertices, from the foci, from the endpoints of the minor axis. So halfway between those would be 0, 0. So I have the center, which is 0, 0. Do I know A? So A is the horizontal distance. I know my center's here. So do I know A? Yes. A is 6. So the distance from the center to one of those endpoints. Do I know B? No. But I do know C. So if I know A and C, I can find B using that foci equation. So I have that C equals what? 4. Okay? So I can use A squared minus B squared equals C squared.
You do minus 4 and negative 4 or positive 4?
So yes. So to get rid of your absolute value, you have to do plus or minus over here on the right side. So what it's going to look like is 36 minus b squared equals plus or minus 4 squared, which is 16. Okay, so we have two different equations. We'll have that 36 minus b squared equals 16, and 36 minus b squared equals negative 16. Only one will end up working. So if you subtract 36, you get from positive 16, you get negative 20. Okay, so b squared equals positive 20. B is technically plus or minus square root of 20. But b is a distance, so we'll just use the positive square root of 20. Okay, over here, you get negative b squared equals negative 52. Okay, so So b squared equals 52. B is square root of 52. Okay, only one of these, plus or minus, only one of these works because I know B, I know that is the minor axis because the foci are on the major, on the horizontal. So that tells me that B has to be smaller than A. Okay? So square root of 52 is over 7. Alright, so it can't be this. It has to be square root of 20. Okay, so now that we have B, we can write our equation. So x minus 0 squared is x squared over a squared plus y minus 0 squared is y squared over b squared. So b is square root of 20, b squared is 20. So all I really care about is what b squared is for this equation, equals 1. So let's do another one like this. We don't have any questions about this right now. Okay, let's do another one. Okay, foci at -4, -3. And 8, -3. I also know that the length of the minor axis is 8 units, but I can't really do that until I find what my center is. So right now, I need the center, A, and B, and I don't have any of those right off the bat. So my center needs to be halfway between those foci, because the foci are equidistant from the center. So if I count just how long it would be from one foci to the other, it's 1, so 1, 2, 3, 4, 5, 10, 11, 12. That's 12 units. So half is 6. So the center should be 6 units away from both foci. 6. And I make sure 1, 2, 3, 4, 5, 6 on the other side. Okay. So there's my center. So the center is at 2, -3. Okay, Okay, now I can fill in that the length of the minor axis is b. That means the whole axis. So from my center, that means it's 4 units up and 4 units down. So that gives me a total of 8 units. How did I know the minor axis was vertical? It's shorter, okay? Yeah, so the major axis is the one that has the foci on it too. So I knew the foci was on the horizontal axis, so the minor axis had to be vertical. Okay, so that's going to give me B. So what's B? B is, the distance from the center to the endpoint, a vertical endpoint. The total length is 8, so B would be 4. Okay? Now I need to find A. I do know C. C is 6. So remember, it's A squared minus B squared absolute value, which means that this is plus or minus C squared. How do you get rid of an absolute value? So A squared minus 16 equals plus or minus 36. So A squared minus 16 equals 36. A squared minus 16 equals negative 36. A squared equals 52. So A is plus or minus square root of 52. Don't worry about reducing your radicals because for my equation I want A squared. So this is actually 2 square root of 13. 52 is 2 square root of 13, but don't worry about reducing those. Okay, A squared is negative 20. Okay, well you can't do that. You're not going to do the square root of a negative. So this is the only option I have to use. Okay, so A is square root of 52. So then my equation so Corey, what will I write with x for my equation? X no, so what's my center? So x minus 2, good, squared. And then it's over A squared. So that's just 52. A is square root of 52, so A squared is 52. Okay, plus, Alyssa, what will I want to write with y? Plus 3 squared over 16, b squared over 4 equals 1. Good. Don't forget the equals 1 part. It's an equation, so it has to have an equal sign. It has to be equal to something. Okay. Questions about that right now? Okay. Let's look at another one. This time we're given the graph. Okay, so to write the equation, we want center A and B. So my center is 1, 1. And I want A and B. So A would be horizontal distance from the center. So 1, 2, 3, 4, 5. Make sure it works on the other side. 1, 2, 3, 4, 5. Okay. B is your vertical distance. So 1, 2, 3. Okay, so we can go ahead and write the equation. Shelby, what will I want to put with X? X minus 1. Oh, X minus 1. Sorry. Good? Okay. Over
5.
Oh, 5. Thank you. Good, good. Hannah, what will I want to put with Y?
Minus 1.
Okay, over 1. Okay, so there's the equation. Find the location of the foci, so we need to do the foci equation. So since I'm not solving for A or B, I'm not trying to get rid of the absolute value. I'll just use the absolute value if I need to. So that's 25 minus 9. Okay, that's positive 16, so absolute value is still 16. But then I do know that it's plus or minus 4 for C. So my distance is 4. So from the center, do I go horizontal or vertical for? Horizontal, because it needs to be on the major axis, the longer one. Okay, so they want the location, so I need to write those as ordered pairs. So that would be 5, 1, and negative 3, 1. Questions about that? Okay, now we want to talk about the definition of an ellipse. So we did this in 7.1 when we talked about the definition of a parabola. You know, we had that distance 1 equals distance 2 for a parabola. So we're going to do kind of that same thing, but this time for an ellipse. So here's the definition of an ellipse, and then kind of the sketch of what that means. Okay, so what that says is that any point on the ellipse, the sum of the distances from that point to each of the foci is constant. So no matter where I put the point, that sum of the distances is going to be the same number. So we just use k to represent whatever that constant is. And the k can change depending on the ellipse you have. So if I picked another point here, then this distance plus this distance would also be k. That's what that means. All right, so what we're going to do is we're going to do a problem and find k. So this is number 48. This is from section 7-2. What I want to show you before we find k is that what I can actually do is set it equal to 2b. And then I only have to find b. And I want to show you the reason why I can do that. So I'm going to show you that k is equal to 2b. So I am not given b. I'm given a. Okay, so I'm able to find a and I'm able to find c. I'm given a and c. But I don't know what b is. All right, so remember I said that the distance from any point on the ellipse to each of the foci, that sum is equal to k. So I can have my xy here, right here, but let's say I put it actually right here. That's a point on the ellipse, right, 0b. That is a point on the ellipse. And so then I should know that this distance here, so I'm going to call that distance 1, plus this distance here, I'll call that distance 2, that equals k. So the distance from the point to each of the foci, that sum is what k is. So let's talk about what distance 1 and distance 2 are. What I need, so here's my center, I need to know that this is c, right? So the distance from the center to the foci is c. So, and this is also c. Okay. So distance 1, what I have here in blue, this part right here, so that is b, right? Because from the center to this point here is b, okay? So distance 1 is b minus c. B minus c. Okay? And then my distance 2, so this one here, okay, that is b plus c. Plus c. Okay? So then, if you do distance 1 plus distance 2, that means you do b minus c plus b plus c. Combine your like terms, b plus b is 2b, negative c plus c is 0. So that is how we get that k is equal to 2b. And that only works because b is where the major axis is. And if the major axis were horizontal, then k would equal 2a. Okay, so it works from the major axis. Okay, and we will stop there and actually find what b and k are tomorrow.